What is a bug in prompt? Bug is something that causes our large language model to hallucinate, generate incomplete, inconsistent answers, go off the topic, drift, and provide incorrect or misleading answers. But what can cause a bug is what we haven't done, prompt engineering techniques that we haven't used, or components of prompt engineering that we used, but we used them incorrectly. So let's see a couple of examples of prompt bug. I provided something just to show you we can't trick LLMs now. So for example, you say, explain the history of Eiffel Tower in Madrid. We know it's in Paris. I didn't provide any other prompt or any other information to LLM. So if we were talking about old models, it could hallucinate and generate off the topic and invented history about the Eiffel Tower. But let's see what it does right now. So the answer is it's not located in Madrid, it's in Paris, and provided the history, actual history. So this means models are getting better and they debug themselves on the fly, but there are other ways that they can get buggy. For example, I invented a word TLMIO in AI, but that doesn't exist at all, and asked the model to give me some detail about that. Let's see the answer. So it's checking in its trained data and giving me some made up answer. So it's giving me year 2023, 2022. But I researched, actually, I was invented that word, but that word doesn't exist at all in AI. So this is one example of a bug in our prompt. The other one, a still bug, is something that is misleading or incorrect, inaccurate answer. For example, what is the latest version of Python? So the latest version is 3.13.5, but when I run the prompt, it says 3.10. It's 3 versions behind. So what we haven't done, for example, here is we didn't use any tool calling or browser component to search python.org and see what is the latest version, and based on that, provide the answer to the user. So this is the consequence of what we haven't done and outdated data of our GPT-4o mini model. So these are a couple of examples that a buggy prompt, but in real world application example, they can get way more complex and needs more refining process to find them and improve them. So let's see one example or case study for us to discuss. We have a refund policy chatbot with a policy we provided to our prompt. So how we can prevent bugs for our prompt and in user interactions with our chatbot? I provide a couple of questions that can cause buggy answer. For example, what if the user asks how is the weather, who won the election, ask other political, religious, etc. questions, or off the topic questions that doesn't have anything to do with our refund policy. But the prompt or LLM is going to answer to those questions. Or the question is really ambiguous about the topic. For example, can I get a refund without giving any more details? So maybe, we don't know for sure, but maybe LLM hallucinate and invent some answers. Or the user asks for a refund, but we don't have any tools to be able to generate the request or get the status of the refund. Go to the user profile, get some information. But maybe LLM generates some made up answers or some unclear questions like, I received a gift, can I get a refund for that? Or can I exchange instead of refund? They are not explained in our policy, and LLM's job is to generate text. So it's going to generate something to answer these questions. So to prevent that or prevent these bugs that can happen in our AI application, and this is for chatbot case, for example, in our case study, we can use two important and advanced techniques. One is intent classification. So we gather more than 7 for sure for a real world application, make it 20, 30 different questions, or using LLM to generate different type of questions that can lead our model to hallucinate, and define different intents that our user they can have. Are they asking for a refund? Are they or asking about a refund policy? Or they are requesting a refund? They want some information about existing refund requests they had? Or they ask unrelated questions, or the question is unclear or ambiguous. So first we classify user intent. What other else we can do here is we say digital products are non-refundable. So what other classification we can do here is classifying products, digital or physical. We are not going to do that in this video, but we can do that as well. So in our prompt, we are using 6 different components of good prompt, as I said, persona, task, constraint, data, output, etc. So in this case, we are giving a persona as a customer support chatbot about refund questions, and we are asking it to classify to these 6 different categories. We are giving a few shots, a couple of examples. If the user asks a question like this, the intent is this. And let's give it a try. For example, what should be the prompt answer if the user question is I requested a refund but never got my money back? So then we give it a try and it says refund status request, which is correct. Or the user asks for a weather. Let's see what is the intent of the user, unrelated question. Or how is the weather today? I repeat it, but let's try it again. Unrelated question. So in this case, when we can classify user intent, I recommend to have different type of classification, more categories. We can use guardrails to prevent bugs in our response. So one guardrail we can put in the response is rejecting unrelated question by simply saying, if the user intent is unrelated question, do this. For example, the answer is, I'm here to assist with refund related question only. So let's say what will be the prompt or LLM answer here. So we classified the user question as unrelated, and the answer is, I'm here to assist only with refund related question. Guardrail for ambiguous question. We define ambiguous questions that they don't have details, like can I get a refund, without providing anything about when they bought the product, what type of product is that, etc., if they have the receipt or not. So let's see. It says, could you please provide more details? And that's the reason, because we define the guardrail here. If the user intent is ambiguous, respond by asking, etc. We can add guardrail for made-up responses. So to prevent the LLM hallucinate. And when it hallucinates normally, in our case, when it doesn't know the answer. So how we put the guardrail is, if you don't know the answer to the question, instead of hallucinating and making up the answer, just say, I don't know about that, contact the support, for example. So it says if the user intent is unclear, for example, respond by, I don't know about that, please contact support. Exactly. So the user question was, what if the item I received is damaged? Can I get a refund? If the model doesn't know about that, unclear, then instead of hallucinating, you should answer by contact support. So as I said, there are other steps we can take to debug our prompt is product classification, for example, and other techniques of prompt engineering. Instead of prompt, for example, providing the policy here as a text, we can embed that using RAG, etc. And what they can do is, when the prompt gets really long, it can mislead the LLM. They can lose the attention on important part of the prompt we are providing for them. So if this is really long, instead of it goes in the beginning of the prompt, for example, the full attention is here, it gets confused or lose the attention and provide the answer to the user. And that can cause some bug as well. So by using other prompt engineering techniques, we can improve and the accuracy of our model and reduce the hallucination of the responses.